Thank you. So usually I give talks that are more low level, breaking things and, and if anybody's caught any of my talks before. This time a little different. I figured everybody's had a couple of days of breaking things and, what I come across typically, and I'll give you a little background and a little funny story to start it off, is, I didn't start off being a hacker or a white hat, and I don't really consider myself one full time anyway. But I got a call one day, and I got a call from a guy named John, and I worked for a vendor. This is back in like 2010 or 2000, somewhere around there. Anyway, it doesn't matter. And he's asked me all these questions, and I'm like, yeah, answering his questions, thinking it might be a customer, whatever, don't know. And we had a great conversation, and I unloaded a lot of great questions deep into RFID and binary payloads and how it works, and I didn't hear from him for a couple of months. Okay, whatever, I have a lot of things going on, wasn't thinking about it. I got a phone call back 2 months later, and it's John. Hey, and he's like, we haven't talked for a while, and I was like, that's cool. He's like, so, I kind of feel bad. I'm like, why? He's like, well, I'm kind of a jerk. I'm like, why would that be, John? He goes, my name's not John. Yeah, okay, it's Bob. And what I do is, I do pen testing, I do red teams, and I was just basically social engineering you for information because I'm working on a project where I'm getting paid to go ahead and break into a place. It was a physical access project. And he's like, they're so heavily secure that I've done all this stuff from like UPSing people into the building, like packing them in a box. He's painted delivery vans to match the brand of the people that do the delivery. He's like done everything under the sun, and he's, the best he was able to get into like where the unloading dock area, but not really anything worthy. He's like, so I was trying to figure out how to do this a better way, and I just want to come clean because I talked to a lot of people, and I just got kind of the best information from you, and you could hate me, whatever. It was cool. So where that leads to is we had great conversations, and he said, Terry, you know what? Why don't you come out to B-Sides Rochester and present? I said, I'm not a hacker. I don't know. I'll be like the dumbest person out there. Why would I do that? And he's like, but even if you're the dumbest person out there, you have something to share, right? So when I give these talks, that's what I do. I share, right? And that's where I'm coming from. And so for the past 10 years, the past 7 years, I've been involved. You can see my B-Sides LA shirt. I organized B-Sides LA. It's a great venue, and we share. And where that story comes from is I've gotten very engaged with people like my friend, and to be on red teams with them to help advise on things to do around passwords, whether it's physical security or info security, alternatives, and where to look for things. And I've learned a lot. But what I've seen that when pen tests or red teams get done, you have some people that are really, really, really good. And they go in and they find a lot of holes, whether it's an energy grid and it's exploited, and a few things happen. The customer can put their head in the sand and say, how can this be? They want to bury it. Or they're taking it all in, and the very smart people that broke it, they got to be smart, they broke it, says it's broken, you need to fix it. And you need to look at some alternatives. But just because you're a smart, white hat or whatever you want to call it, a researcher, it doesn't mean that you might really understand the depth to advise an enterprise organization, whether it's energy or defense, on how they're actually going to go spend a few $1 million to go do this where it's successful and people don't get fired, right? And so for my job for the past several years is I'm a hired mercenary by these large Fortune companies that take on these initiatives to figure this out. And on the surface, it's very easy. We all know what these things look like, whether there's a smart card or a token, but at the end of the day, all the crap that goes along behind it, the million ways you can do it wrong that you probably will, if you just stay at the surface level, you'll do it wrong, and heads roll. So I'm here to share my knowledge around knowing both sides, but lessons I've learned over the past 15 years of doing this to help people understand the technology around the alternatives. What are the alternatives from passwords itself? Let's kind of break it down. So there's some fundamentals, and then there's stuff around like, obviously what would my opinion be around those alternatives. And for some reason this is not working. I have a Microsoft Surface freeze up. Great. It's a keyboard thing. You gotta love it. Okay, so while I do this, and hopefully it works, so we'll talk about those alternatives. I'll give you my opinion after working with them for a long period of time as to how they perform, how they scale. And my bar is how well are they gonna scale? Because if they don't scale inside of a large enterprise, then they might work in a small enterprise, but you can't really take what you learned from a small enterprise and scale it out. But you can do the reverse. So you can go through the best practices of a large enterprise and learn a lot of things and then apply it in a smaller sandbox. This isn't good, and I'm hoping Microsoft doesn't make me do a reboot. This is pretty terrible, and I apologize. Maybe if I just swipe it. Okay. It wants a swipe. It doesn't want any. Oh, the swipe just kind of got everything going again. Okay. All right, so I'm going to take this in 3 parts, and I'm going to take this really, I want to differentiate between identity and credentialing, because a lot of people think about a password as identity, or you got into something, so that's your identity. And identity and credentialing are 2 separate things. They're very relevant things, so we'll review that as a fundamental. And there's going to be things in here that are fundamental. So some people might get bored, but we'll get into the weeds later on if you want. And we're going to take this from a vendor neutral approach. I'm not mentioning any vendors. I don't work for a vendor. I don't drink the Kool-Aid. Most of my time is spent where vendors probably hate me, so it doesn't make sense to plug them. And really, I want to take this from the approach that when you tackle a password alternative project, that you're going to have to go through a high level of scrutiny on your plans, on how you're speccing out, what resources are involved, how much money is going to be spent. So I'm not going to spend a lot of time on ROI, TCO type of business stuff. I will spend a couple minutes on it, just give you like a viewpoint if you want to spend more time on it. But all these projects, when you're going in to propose something large scale or critical that's got to work, it's got to protect, it's got to do all these things, and we'll talk about those things, it goes through a lot of scrutiny because it involves many filters, many people, many types of resources across different management infrastructures. So it becomes very challenging and people lose patience. And what I want the audience to walk away with is, I want you to be able to get through the vendor Kool-Aid, because all vendors go in and there's like 200 vendors in this alternative space, password alternative space, and they all kind of give their Kool-Aid and they really believe it. They just, and if they go work for another company, they believe something different. But the customers, they're going to own whatever decision they make. So I know that most people in this room are probably independent. You probably don't work for a vendor telling you what to think. We're independent thinkers. So I want you to walk into an organization and say, where do I start to assess this? What might be the right path for them? What might be the right solution for them? And what's the right process to kind of bring them through to think them through, okay? All right, so my whole thing is, I'm not gonna review things you already heard of, but if you look at how all these attacks are executed that we hear about in the news a lot, a lot of them have password elements to them. It's not the only element, but it's pretty much what I see as a common denominator. And so you can even look at like whether it's a Verizon breach report, and it's like most of these breaches involve some element of password or identity exploitation. And that's a reality. So when I look at what organizations are doing or what they didn't have in place, I'm kind of stunned that they haven't kind of gotten their act together with either strengthening the password, other processes in play, or other alternatives. And sometimes it can just be they did 90% of it or 95% of it, but in that last 3%, the attackers were able to find where they were vulnerable, where they didn't have it completely implemented. So that's my whole thing, to get people thinking where I'm coming from. Now, where I have to go with this is what's identity? Because if you're doing a credentialing program without a concept of identity, you're pretty much hosed, in my opinion. Okay, so I want to take you through that very briefly. And so identity really is separate from a credential. An identity can be where I would say you have different attributes that make up a person's identity, right? Traits, for instance, they're things that you can't change. I mean, arguably these days through genetic modification and stuff, yes, but generally, eye color, height, and all this stuff you're born with. You would have attributes maybe that get assigned to you. Last name, an address, an employee number, a driver's license number. These are all things about you, okay? These are all things that when you go to an organization, they have to manage and associate with you. and things change, and they have to make sure that it applies to you, and they have to understand that context. And then the thing that really makes identity a lot of work is not just updating the attributes, but relationship. I mean, think about it, as my relationship with my organization changes, or my role changes, which my relationship may change, what I can access, or what I can do, or what I should do changes. And so we get into, that's really the bulk of the identity management work, is managing the relationships that I should have and the entitlements that I should have. And that has nothing to do with the password that I'm assigned yet, okay? Or the token that you give me. But what happens is roles change, relationships changes, okay? So that's this whole other thing. That takes a full, in effect, program. It's a separate program, but it's a focused program. The credential I look at is the proof behind all that. So once I have the identity locked down and I'm managing the relationships and the entitlements, the credential is a representation of who I am to be able to execute a challenge and a response to prove who I am. And it's up to the program, whoever's managing the program, to make sure that's either a strong or a weak challenge response, okay? And I'm not sure I'm really gonna go through a lot of this because my animation isn't working, so, well, oh, it is if I swipe, okay. So my point here is that you go into a commercial organization, an enterprise, and I would say that you walk in with existing identity attributes already, right? So I have a Twitter account, I have a Facebook account, I have a driver's license. They're all disconnected, but they're all things that identify me. And why that's kind of interesting is because when I go to HR, they want me to prove who I am, even though they kind of know I show up for my first day of work, right? And what do they want? They want a driver's license. They want a bank account number. They want to put you in payroll. They want to do a background check to make sure it's your bank account and your payroll, all this stuff. So you carry these third-party things that are already assigned to you into the enterprise. They piggyback off them, and then they put you in, whether it's performance management system, talent management system, payroll. Now you have separate identities within their system. And then they tell, hey, IT, he needs access, right? So they'll tell IT that, to set you up to get you access to what you need according to your role. And now you're in AD, you're in disconnected applications, and this is where you have the problem where some people have 20 different identities inside of an organization. So it takes work, and then physical access is a whole different story because that's usually disconnected, right? So that's the story with identity. It's completely separate. Now, I need to go in and say, okay, well, credentialing. Let's get into the credentialing part. What credentialing is appropriate? Well, I got to look at the risk. I got to look at what people are doing. If they're just accessing a lobby, well, they're going to get an RFID card and doesn't really probably need to be a very strong one. You could argue with me, but I'm saying they're just getting in the lobby, right? But if they're getting access to a data center, or let's just say they're getting access to an HSM, the person that manages HSMs, where all your crypto keys are stored, I mean, you better make sure that that is a really strong credential. So not everybody in the whole organization needs the strongest credential. It can be mixed, right? And you have to look at that because the stronger you go, the more complex and more expensive it is. And I want to spend according to my risk because I can't afford to just go ahead and spend millions all over the place and overspend. But it's not just about the technology, and this is where people fail. It's about how you proof that identity. How do I, upon enrollment, know that it's the right person being enrolled? What's my process to ensure that? How strong is a challenge when somebody busts out that credential to authenticate? How strong is that challenge in terms of how well it could be manipulated, forged, or otherwise? And then the response. What's the response? Is it symmetric key? Is it asymmetric? And then the validation part of it, right? So there's all sorts of validation processes and trust models that we'll get into, that how much trust do I put in that credential? So, and all this is a lot of process policy. It involves, what type of crypto you're using, who's performing the background check, is there an anchor of trust, right? Is there a practice statement where they audited? So the world of just issuing a one-time password token, it sounds great on the surface, but a lot of times they're void of all this, which might be fine for the application that you're doing, but it may not. And it takes individual analysis across the spectrum of your assets to find out really which one is appropriate. And that's separate from, does vendor A do it better than vendor B? right? That just comes down to the premise of the type of technology and the general policy that I require, right? I'm going to skip through things and I'll take more questions. Things that we'll talk about a little bit more, I'm going to get into the types of credentials in a second, but when I mentioned about the process, the policy, a lot of it comes back to this stuff, right? So how are you going to vet the person that it's really them when they enroll, but also when they come and when you issue and distribute their credential to them? Because maybe it's not, maybe they're gaming you, it's not, maybe they're getting you to distribute the credential to a rogue user, even though it's a real person that enrolled, and you need to make sure that that's pretty tight if you have high security stuff going on. So that's the adjudication piece. Background watchdog checks, sometimes that's critical, like, hey, they passed a background check and we vetted them when they first came in and got their credential, but 3 months later they got picked up for some crime, and so it's always kind of, maybe some organizations have this rolling automation of a background check that goes out to federal systems and see if somebody was okay, but they're not anymore. And then you have secure issuance where, when you're provisioning the keys or you're doing a key ceremony or anything like that, that the communication between the authoritative source and the key store down to the client or the device itself can't be compromised. Which is why, all these upstart companies that just say, no big deal, you don't really need this infrastructure to do key management, and they just be like, yeah, all you do is kind of like this, P12 file, and you just offload this P12 file and you put the key in the device, and it's like, that is not very secure. And if you have a lot of people doing the issuance, I don't recommend it, right? So you need infrastructure, and you need to make sure that the points upon issuance, delivery, and activation are very secure. Perhaps, maybe you determine it doesn't, but I'm going to this end because you can always go backward. That's where I'm coming from, right? So, and then it's the application security of the product itself, which everybody's familiar with, because security products don't always mean that the product itself isn't secure, even though the functions try to deliver it. And lifecycle. Lifecycle's huge. When you start to get into organizations that have remote people and they're disparate, they're on different campuses, they're flying around the world, how do you handle when they lose their PIN? How do you handle when they lose their credential? Are they calling help desk? Can you get the device to them? What if they lost their phone? A lot of these systems are, even the mobile device approaches are, and I do a lot of advisory with end users and get hired as a mercenary and a lot of Q&A with vendors on how they do things. And I can tell you, in the mobile world, a lot of them are assuming that, we have help desk automation for that mobile device to get your virtual credential back. And most of the time it's based on the fact that it's the same SIM and the same number. That's all they look for. And there's no intermediate approval or delegation. And but if you're a large scale enterprise, you're gonna face all these things. People lost their phone. Somebody took their SIM. They dropped their phone, it broke. It's in the bottom of the river. I don't know, but you're not gonna want all these help desk calls all the time. And those help desk calls start to turn into spear phishing calls. And so anyway, it's a lot of that stuff, okay? All right, so let's go through some of the basics. This is the basic stuff, something you know. And we all know what that is. Generally, it's gonna be a password or a PIN or a question-based answer, response and answer. And all these things are based on memory. And I think we all know that they have flaws. I'd like to point out that passwords I don't think they'll ever go away, and I'm not justifying their existence. It's just they come with the application, at least this day and age. They're for free, right? So if you go buy an Oracle database, guess what? You're getting password functionality for free in that database. And Oracle's just unwilling at this point in time to do anything else out of the box that scales across any other. They see it as not their responsibility. So guess what? Passwords are going to be here for a long time. They just will. And you can decide whether they're still in play. They're still in play for different audiences or applications. But the reality, in my opinion, is we've got to move beyond passwords for some of our assets and groups of users because we have different levels of risk. And that's where I'm coming from, okay? Okay, so I'm going to skip over that because you've had 2 days of that. Something you are, biometrics. Basically, it's a biometric. And they come in all forms: iris, facial, palm vein. There's all sorts of things, heart rate, heartbeats, and there's on the surface they look like they're the holy grail because it's you. How could it be anything but you? And how can you forge something unique to you? Well, I can tell you, I work for one of the leading biometric companies, and I can tell you there's a lot of things about this technology that is flawed. that doesn't get press. So it's pretty funny when I see that there's challenges out there like Apple, or there was who was it? Challenged somebody to break the iPhone biometrics. People were spoofing, and they proved they could spoof the finger, but there's a much easier path to this that people didn't take. And I was sitting there, and we'll cover why biometrics in some cases I think are good, but you change the context and they're terrible. And I'll just expose you to the facts that I know, and you can decide for yourself. But in a general sense, one big problem is you have no revocation. Right? So I mean, if somehow my template, and I'll explain how they work in a minute, my template gets compromised, I can't create another finger. I can't derive another template from the same finger. It's going to be the same template that was compromised. I only have so many heartbeat signatures, probably one, I would imagine. I don't get to enroll different heartbeats, and so you have a problem with revocation. And whenever you can't revoke a credential, I don't think you really have a secure model, because once it's compromised, you are completely screwed. And there's a lot of other problems with the technology. The short stories are great for identity, terrible for authentication. I'll get into that. We'll do kind of a technical section after this initial what's out there section. And then something you have, right? So that could be an RSA token, an Oath one-time password token, SMS, smart cards, PKI. I've seen, how many people know what a scratch card is? Yeah, scratch card. You get a printed card with, it looks like a bingo layout where your application says go to B29, and you read off the numbers that are in B29, and only the issuer knows what was in that spot. And it's cheap. It fits in your wallet. It's a piece of paper. So you're not buying a $10 token. You're just printing out paper. So anyway, not to get into that. And then you have some organizations that are trying to just say, hey, your bank already knows who you are. Just use your bank or ATM card. Scary, but it's happening, okay? Along with, using Facebook to log in to whatever, which is not a good idea, but okay. So I want to talk a little bit of the components about lifecycle before I get into reviewing the technologies, because the technologies itself are dependent on whether they can do some of this stuff. When you're thinking about a project for alternatives, the biggest mistake that I've seen people make, and I've done this inside of many, many large organizations for the past 15 years, is they head right to the technology and the device. Oh, I think one-time password. I love this device from Vasco. You push the button and it's U2F and it'll do this, and that's what we need. Stop. Or they think they need a smart card and they Google who makes smart cards, and they get the vendor in there, and the vendor just wants to sell smart cards. And they don't talk about all the things that you should know, and you wouldn't know them yet, right? They don't talk about keys and key ownership and integration and all this stuff. Just everything works, right? So the first thing is that you really have to talk about your business process. Well, first, I'll go through this. Outcomes. What do you want to achieve out of this? So it comes from stakeholders, and what are you trying to secure? What are your assets? What are the outcomes? But from a technical standpoint, I really need to understand this stuff. How's this going to integrate with my back-end systems? Whether it's, help desk from Remedy, how's it going to integrate? How's it going to integrate with my IDMS or AD? Is it going to impose schema extensions in AD that I really don't want to go through? My IAM people don't want to go through, but I haven't even talked to them yet. So I don't want to have to go ahead and say, great, I got a great deal on this shiny new thing that I thought we needed, but it comes with a $2 million dependency that I didn't think about, that we have to do to upgrade or something to execute it. Or I've seen this happen. They buy 50,000 of these devices because the vendor sold it on them, and they stay on the shelf and collect dust because it wouldn't work with their back-end system. I've seen it happen. Just stays there on the shelf. Not good. You don't want to be. So you want to be able to figure out the life cycle, the type of events they're going to experience, from locking the device, losing the device, how you're going to get it to them are highly distributed, and do the workflows to be able to have that as an interface or a process support the life cycle. And do you get reporting throughout that life cycle to have an audit trail that things got issued, who issued it? A lot of these products don't, believe it or not. So if somebody issues a credential, man, I really want to know who had the ability to issue this credential. Did it get activated? When did it get activated? I want to know this, right? See, it's all this stuff that seems logical but is missed when we're just thinking about a credential. And your infrastructure, the type of integration, and of course all the security stuff that we want to talk about. And it's not just about the device. It's about dependent systems. It's about It's about the distribution. So if you're getting the devices from a third party, like a token, somebody manufactures a token, what's their manufacturing process? How do they protect their keys? Who has access to that manufacturing? And so it's not a cloud, but if I order tokens from ABC company, I want to know that their process isn't compromised, because at the end of the day, they have my seeds that I load into my server before I get them. Or whether it's other things. So you got to think about these things, because they're really something to think about. In a flow of how you might issue an advanced credential, you might go through a vetting process, okay? So it could be like a government issued ID that gets leveraged, references, a bank verification, the bank already vetted you, some type of accrediting, licensing boards, they already put you through the ringer. And then so the party will go ahead and say, okay, we trust it, we're gonna go ahead and issue you one of these, right? Now, before you use it, we might go ahead and do a live interview, do some background checks, this is all optional. And then we're gonna go ahead and do binding, adjudication. You have to come in person, you have to do a bio before we hand it over, and you have to activate it in person, or you do it remotely. So there's these intermediate steps of making sure that you are the person enrolled, and I'm gonna give it to you and allow you to do activation. But then you go through, the usage part, right? You might have a remote activation, and then of course, you kind of have these other instances of, it's not just whether it can authenticate, but it comes down to whether you want to provide self-service to people. If I have 100,000 employees, man, I better provide some level of self-service, but it better be secure, or choose what parts of it that I want to have self-service and other parts get on the phone, because this is a high-risk scenario. The other thing is I'll talk a little bit about what I call relying parties and IDPs. Who's heard of relying parties, that term, and IDPs? So, in the traditional sense, we think of ABC organization issuing credentials to their employee, and that's the way it flows. And that is the traditional model when you think of giving RSA tokens to people, in your network. But at the end of the day, it could be where you have another organization that you are doing business with that has their own set of requirements for your employees to access our system, right? And they will be a relying party, and they're not going to be the issuer. So you have the issuer, the relying party, and a lot of times, most of the time in the models that we're talking about, the relying party and the issuer have to be the same, and it creates a lot of burden, right? But you have new models coming out where the relying party doesn't have to be the issuer, right? And either you have some really hardcore interoperability to get there, like how many people have heard of PIV? It's a government spec for smart cards. How many people have heard of Common Access Card, CAC, right? So everybody in the military, whether you're DOD, Army, Navy, they have a card with a chip in it, right? That's a CAC card. The next generation is a PIV card. And the whole premise behind the PIV card is interoperable. So if I get issued a certificate from a CA within the department, certification authority, then there's another department that can go ahead and validate that it's valid and call the OCSP, because at the federal bridge level, they have some chain of trust between them. So they're not issuing from the same CA, but they're chaining their trust, and they're certified to be able to do that. Highly complex. Not something I would advise a commercial enterprise really doing. It's not there yet. There's other ways to potentially get there. Okay, so I'm going to go into each technology for a few minutes, and then I'm going to talk a little bit about project stuff. Before I talk about each technology and give you my opinion, we can make this a discussion and you have questions and whatever, is how do you sniff out the BS? And what's the BS filter for the vendor pitch around I have the latest, greatest thing, right? So there's a lot of elements, but here are some key elements. And this is what I find as an analyst. I go do requirements for large scale end users. By the way, I forgot to tell you, this is all posted online on my website, this whole deck with notes. And it's on my website. You go to D6 Research, you go to resources, and it's right there, PasswordsCon 2016. And I'll go back to the original slide, give you the links. So it's all there. You don't have to take photos. You can if you want, but it's all there for you. And what I say is, there's a best practice model where things are open. And I like open stuff, not because it's cool, not because I think I should get everything for free, but when things are open, you put it out there for peer review. everybody gets to kick its tail around and tell you how good or how bad it is, and that feedback comes in, and it goes through a process where everybody wants to get it fixed, and everybody's taking the bus to the same location. So if somebody else has a comment, and the community wants to fix it, it's good for everybody. When I'm in what I call an obscurity model, where they won't tell me what crypto algorithm they're using, oh, I'm not going to tell you. That would potentially compromise my solution. Well, I'll tell you what, telling me your algorithm or how you manage keys should not compromise a security solution. You should be able to tell me everything but the private key, right? Or the files to reconstruct a master key, which I wouldn't ask for, right? But I would want to know a lot of things about how you have built your solution, how you manage it, your custodial responsibilities. And here's generally what I would say the good responses are, right? And here are the ones that I typically get where I say, okay, you know what? Deal's over. You pretty much eliminated yourself because this model right here, I can tell you, can not just be broken, but once it is, it's not fixable, right? That's a problem with the obscurity model, right? The open model, you can always iterate, you can fix, everybody's getting on the same bus, go to the same location, it's open. You'll probably catch that stuff before the standard becomes in use. But this stuff, once you compromise it, it's broken because they didn't do it right in the first place, and that's the problem. And so if I take a look at all the technologies I can think of, everything from access cards for physical access and barcodes to PKI certificates, and I think about how strong they are, and I did this a couple of years ago to kind of just start doodling around and, thinking through things and doing an assessment of all these technologies, of how strong they were and what their security models were. I don't know. I wasn't sure where I was going, but it dawned on me that really what happens is that all the weak ones down here, if you notice, that they really aren't big on standards. Just coincidence, right? And the ones that are really strong tend to be more in the standards bucket. And again, I think it's because that peer review. If it sucks, people are going to sniff it out. It's not going to get to scale. It'll get fixed. It gets vetted, right? By the time you figure out there are problems with SHA-1, it's already on SHA-2. You know what I'm saying? So that's very, very important. Okay, all right. So I want to go through some of these and then get a few points in on some business stuff and take questions. But proximity cards for physical access a lot of times stink. How many people have been to talks around breaking proximity cards and stuff, or you've caught one of my talks, and right? There are some proximity cards that are strong, okay, that have not yet been hacked that I know of. And I've peeked behind the covers pretty deeply, and it's a matter of time perhaps, but right now they're much stronger to the point of not associating with maybe the talks that you've seen where you've seen them get exploited, okay? I point that out to not put them all in one bucket, but here's the thing. Even those highly secure cards, which are the minority of the time that you might encounter in an enterprise, are terrible for authenticating to IT systems. Context changes everything. And the reason is because embedded within that RFID card is a vendor-programmed numerical character in binary, right? So let's just say they encoded a 9-digit number, right? It's it's a number. It's just numerical format. That's what it is. That's all it is. Now it might be encrypted, but here's the thing: in the system has to know what number it is after it's encrypted. So that's a number that's stored without encryption. That is actually figuring out how to authenticate it. Right? So that's probably the number that's going to be in an Active Directory, number one. Number two, the source of issuing that number is being used in physical access software. And the physical access software generally, and I can tell you for a fact, for me to go get into an organization and get into an access control system and start peeking around and understanding what somebody's card access number is without the encryption, not terribly hard. So I can find weaker points to get that number in unencrypted form and reapply it. And now what am I left with? I'm left with everything I don't want to do. I'm left with a number that's encoded by the vendor, a vendor default, which actually goes against a lot of audit policies for good reason. I'm left with somebody else encoded it, and they have a record of it, and I have no idea how they're managing those custodial relationships or those records. That's pretty bad. A lot of times they actually encode the number right on the back of the card. Bad practice for a different reason we'll get into. But I can't change it. My whole password policy of changing the password every 30, 60, 90 days, I have no control over that anymore because it's hard coded into the card. And there's no process to change that. So everything I thought I was getting to go to a more secure model, I'm actually taking a step back from where I was and being able to manage passwords. I would say passwords are better than RFID cards for IT security. Yeah.
Sorry, but you're saying the passwords are better because they can be required to be changed every month?
Because you can change them. You can't change the password. What's that?
Repeat the question as well, please.
The question was, am I saying that passwords are better than RFID cards? Because RFID cards, you can't, because you can change the password. You have a password policy. And I'm saying yes, because if you have a credential, you have a password policy that you could impose changing every 30, 60, 90 days, right? Or whatever it is, but then you implement a credential that has a password, because it's a password in that credential, and I can never change it at all. And I can't make it alphanumeric, and I can't apply any of the policies that I previously had. I would say stay with your previous policy, because at the end of the day, the authentication process has no idea that you're using a card. It's just reading that sequential numeric string.
Well, it's not a password, it's a serial number.
It's a serial number.
Right.
Yeah, it's an encrypted serial number with a obscure format, and it's not doing any type of random number generator process to make sure that you have the device, and it's just basically, you have that matching number. It's terrible. It just takes you a step back. And this is, I wrote a paper on this, it's on my website, and I saw a lot of organizations doing this because they wanted to use the cards they already had, and since it has a chip and you can't see it, all these companies were doing it. I said, oh man, you just got to know what you're getting into. So anyway, that's the story with that one. Oh boy, biometrics. How many people here like biometrics? Some people. Yeah, like to break them, So biometrics for me is an interesting topic because I worked for a biometric company, and I'm not going to talk about them, but what I'll say about the biometrics is there's a lot of problems. And again, I have a paper on this. You can go check it out. It goes through all of kind of what I think. At the end of the day, there are two types of biometrics. One's called AFIS, which actually does a live scan and it's a real photograph of your finger, and that's used for law enforcement generally. Okay, so when you see like CSI and they have all this blue beep, those systems really work like that. It's kind of amazing. They have all the sound effects. But really, what's used for authentication is a template, which is a mathematical representation. So you'll do a scan of your finger. It'll interpret that, all the data points and the ridges, in how that software and algorithm does the interpretation, which is unique from vendor to vendor. What's unique around the vendors, by the way, is the algorithm and how they interpret those data points. And it gets into a mathematical representation, much like the gobbledygook you would see in a PKI certificate, okay? And what it does is the next time that you go ahead and apply a live finger, it recalls that reference template that was enrolled and compares them. And every time it does that, it's a mathematics thing. It's not security, it's mathematics. They're trying to figure out, does this blob match this current real-time interpretation? And inside of that, they're not always right all the time. In every biometric system, there's a false accept and a false reject rate. And you typically have control whether you want to have more false accepts and more false rejects. You get to tune it, but you can't up both. It's one of these, okay? And so if you're in an organization where you can't have any of those false accepts or false rejects ever, you can add a third factor, or maybe biometrics isn't for you, right? And I'll say that I've seen bugs in some of these biometrics products where if you put your finger in a certain part of the sensor, then it throws the algorithm off, and it's like, yeah, just let them in. So it's sometimes not that good, right? The biggest problem with biometrics that I have, it's natively most applications in the IT world don't know what a biometric is. They just don't know. They know what a password is out of the box. They don't know what a biometric is. The applications are learning what a PKI certificate is, but they don't know what a biometric is. So what does it do? The biometrics vendors that you buy will go ahead and say you must deploy this middleware client. This middleware client, you basically stores a reference template to compare to the live finger. It also contains logic to do the comparison in runtime. And then it also has another component that takes your existing password that you're trying to get off of and encrypts it and stores it in a local cache in software. And then when I do a successful match, it will decrypt that cache and send that password back to the application for authentication. So all I'm doing is I'm adding a layer of abstraction, but all my back-end systems are still dependent on that password. What did I solve? I didn't solve the problem in the back end, which is a lot of my big problem. You know, if I'm going to go ahead so anyway, there's a lot of problems. You're still in a password paradigm, and it's very expensive. It doesn't do encryption. It doesn't do a lot of things that you want to do, right?
I'm curious about the nuance real quick. You say
Yeah.
generally doesn't encrypt, and then you say can't encrypt immediately afterward.
Okay, so there's three things around encryption.
It can't hash it, right? But
Yeah. So the password is going to get encrypted in a local cache for use upon when you have an accept, right? And it's going to pass that to the application. And typically that middleware is implementing its own process of how it deals with that process. And that's just encrypting the password. That's one part. The other part is, do they encrypt the template? Because if somebody takes my template, I get into that whole revocation model that I talked about, right? And then there is the other part where I care about authentication, but at the end of the day, I really care about protecting my data. And I may want to go ahead and do SMIME. I want to go ahead and do full disk encryption. I want to encrypt the stuff that's critical. Biometrics don't do that. Now, you can get fancy with biometrics where they add elements in there, but inherently the technology just doesn't do that because it's not key-based, it's mathematical-based. And all these vendors in the biometrics world, the conversations I have with them are typically they're mathematicians or they're marketing, because their whole business is building great algorithms, or as great as they can, and with that, they don't focus on security. They're not people that understand application security very much, but they certainly know how to market to the security market based on the fact this can only be you. But when you start to peel back the layers, that's a challenge.
So are you suggesting then that anyone using biometrics should use the biometrics not to grant access to anything but a key as part of an additional factor?
Good question. Or yes. So I like to say if you want to use biometrics, use it for identification, but not authentication. Because identification systems typically understand what a biometric is. It's kind of native. And you could say, for example, if I'm going to go ahead and use one credential, but that process doesn't check whether I'm the right holder of that credential, the biometric can help do that. Yes, I had the right person, they have the right credentials, so you can use both. But you may be advising an organization that's resistant to doing three-factor, right? So that's why smart cards use a PIN, all right? And the PIN, you have policy behind a PIN, that's good. I'm not gonna go through, this is physical access sort of cards, data stuff, and anybody wants to talk to me about the payload that's on there, we can do that later. So one-time password tokens, everybody knows what that is, right? So I'm pretty sure whether it's SMS, on a mobile phone, or a token, and they're pretty good. The challenge with that is that they don't do encryption. They won't do Windows login. They won't do full disk encryption. They won't do SMIME. There's a lot of things they won't do. They'll do VPN or web apps pretty good, which is a benefit, right? So if I'm doing public, private cloud stuff, and they're pretty simple to implement. I don't need a lot of infrastructure. I need a few things, and I can get going pretty quickly. You still need to think about all that lifecycle stuff that I'm finding a lot of these upstart vendors that are getting a lot of funding, they're missing. They're just getting into the space without really understanding how you deal with lifecycle events at scale. And I find that their technology in use is good, but the management of it is lacking, right? And a lot of times they don't have the visibility into this, so they're well intended, but you have to fish that out. I get into smart cards and certificates. So smart cards are pretty cool because it's public-private key. It does all the things that you might want to do. The private key is always protected in the device. You have policy, so only the person that's issued can operate that device. It can do many different things. and it's incredibly secure when you implement it correctly. The challenge is you need a lot of infrastructure. You need a lot of key management. You need a lot of things to make this work correctly. And of recent times, the challenge is not only that it's complex and resource intensive, but it's terrible for mobile and cloud. And most of my clients that did smart cards a while ago are killing off these smart card projects because the vendors haven't yet figured out how to really implement it well for mobile and cloud. And that's where their executives said, you know, we're taking some applications there. You know, access to everybody all the time, too bad, right? So this is starting to be addressed, but it's going to be a little while. And one of the things I like here is U2F. So U2F is pretty cool. It's not the end all, right? So U2F is a specification, it's not a standard. And U2F fills kind of this thing where if you like asymmetric, which I do, asymmetric key, public-private key, the private key stored in a secure element, never leaves the device, and smart cards were never really built to work with web interfaces well at all. U2F was created by Google and Yubico doing some things and saying, hey, we should open this up, where it integrates at the browser level without having to go ahead and install any drivers or middleware. And it addresses that web scenario in a very simple, consumable way very nicely. One of the things that it doesn't do is it won't do like SMIME, and it won't do all these other things it might want to do with a smart card. But to keep in mind, what you can do is you can virtualize U2F. This is what's coming next. You can virtualize U2F and as an applet and shove it into a secure element where now you have the best of SMIME and U2F without drivers and all this stuff. The biggest thing about U2F that is really groundbreaking is that the way it works is how you go, you get issued a device from whoever, and you go to a service. Let's say it's ABC, let's say it's Amazon. Why not, all right? You go to Amazon, and let's just say they have a U2F server and a U2F service. I can go there, and I plug it in, and I register it, and what it does is it issues a private key directly to my secure element, right? It takes my device ID that has a public key, and it says, oh, okay, I'm gonna issue a private one that's only bound for this service. And then I can go to another place that's totally disconnected from Amazon or who issued it to me and repeat the process. And so U2F can go ahead and support multiple different U2F services or relying parties without the relying party actually issuing the device. So it solves that problem that we talked about early on, which means you have immense scale, or if I run a forum and I want strong authentication, I can just do a risk score and say, hey, anybody that wants to use their U2F device, we have a U2F service, and it might just point it somewhere else, and people can use their U2F device, right? Public-private key and all that stuff. What else do I want to talk about for a minute before I go into Q&A? There's some business stuff. The last thing I want to talk about for a minute is, so what do you do at the organization level? I like to say you don't go in there and say, hey, I want to fix all your problems. It's a technical problem, because there's only so much money to go around, and the CISO's looking at it like, okay, yeah, this is important, but it could be number 22 on my list after you talk to me, right? So I like to say, okay, let's work backwards from a threat model standpoint and say, look, what's most likely and highest impact? And you kind of do this for every organization uniquely, because this is generic as an example. And right here, if you can find there's several that are likely and high impact, a CISO is going to start to say, you know, I can kill 3-4 birds with one stone. You know, that might be worthwhile doing. And you can start to build that technical case. And then you need to build that business case, because there's some elements where I had a client where the CISO was bonused on trying to go ahead and find additional use cases for security. And then the CIO, and this is a $10 billion organization, the CIO wanted to actually prove to the CFO and the CEO that he could be a business executive. So he was trying to figure out how to address problems that would save him money. And then so what you ended up with, the solution would help them actually reduce a lot of their office space by virtualizing things and using thin clients and unique identities, and they lowered their tax liability. So the CFO got on board, the CIO got on board, not for security, and they're pushing through this $10 million project, all because different stakeholders. It's not just a security stakeholder. thing that you're selling to. You got to translate security at the value of security, which we all live in, that's secure, it's going to do what it's supposed to do, and it's going to reduce risk. But in order for a CFO to fund it, you got to get them something. And sometimes it's reducing areas even outside of security, right? And I have models around this if you want to talk. But my parting words, I have other slides, but I'm not going to get to them. But my parting words would be, when you go into this project, you have to take a technical track and talk about the vulnerabilities and assets and controls and whether these things are going to do what we're talking about. But at another level, you have to figure out who the stakeholders are and get their input. Because without finding out who the stakeholders are, you don't really know what the capability of this thing needs to be. What are the use cases? For who? Who's going to be using it? What are the barriers for acceptance? Will be user mutiny. And then from there, you translate it to compatibility and technical. Don't just take the technical track. Seek out the stakeholders that aren't in security, get their feedback, know what this thing has to look like, what it has to do, what the success criteria is. You have all those elements, you can start to build a TCO, ROI model, a technical model, and then it can be interpreted by different stakeholders to have those real discussions. Because without it, you're going to run into barriers where they just tell you no. Somebody's telling you no, it's because somebody else above said, I don't have time, this isn't a priority, and you just get shut down not to get to the bottom of it, right? So, okay, I'm out of time. I'm going to take a couple of questions maybe.
Questions? Raise your hand.
Put up your identification slide, your last slide.
The last slide?
Your GitHub link or your name.
Yeah,
Oh, well,
So there's a slide with a link on it.
contact information, basically. For
okay,
you.
so I have my contact info here.
Ooh, yeah.
And then the link I have is on the first slide. I probably should have it on this slide. So everybody kind of got that. And I'll throw it to the first slide in a minute so you can get the link to the prezo.
Yeah.
Yeah. Then you go to research and go to resources, it'll be right there. So.
One of the things I do back in Norway, Terry, is I teach the ESOC Certified Information Security Manager course. And every time I have students doing that, the first thing I do on day one of the course is to ask them to write down the vision, the goals, and the strategy of the company they're working for. It's always kind of fun to see how people react to that because, well, I'm working with security, why I'm supposed to know about the vision and goals and strategy of my employer. And I teach them something else. Okay, questions? Oh, Jeff, somebody else? I'll do this.
What's wrong with Jeff?
Oh, I talk too much.
We'll cut you off. It's fine. Awesome.
All right, so with multiple factor for replacing password, how do you deal with recovery? Particular, let's say you use some new factor, U2F token, you lost your U2F token somewhere in Vegas.
Yep.
So how do you recover access?
So U2F, for me, the way I see it is kind of a problem right now. It's immature. But if you go to something like, let's take a smart card, for example. Right? So for like a OTP token, you're going to reissue a new one. You're going to reissue a new seed and either a new token or associate that seed to the virtual application that you pushed out. But a smart card is a good example because like U2F, it's based on a PKI model, right? Because they're both X509. And the reason why I use smart card is because it is a mature model, maybe not as scalable as we want for new uses, but it's a good model that that's where it gets back to key management. So the first thing I would do is I'm going to go ahead and do a transport key with the manufacturer of the cards. And then when I receive the cards, I'm going to do a key ceremony to create my own master key set so nobody else knows them, even after transport. Okay? Now I manage all my own keys. My certificates are in my own CA or a third-party CA, whatever it is. And so what I would typically do in that scenario is I would go ahead and issue you new authentication and signing certificates, but I would do escrow of your authentication certificates, and upon issuing your new smart card, I would go ahead and issue you I would issue basically key history. So anything you previously encrypted, you can decrypt in the future. And that's where PKI and key management gets very difficult because now you're getting into key management escrow. and recovery, and how do I go ahead and get key history out to somebody that's across the continent. You can do this in some of these modes through clients and, and automation, but it's got to be rock solid. If you have 10,000 users and they go through a process that doesn't work half the time, or they don't know what's happening, well, nothing is showing. But it's really going to be around escrow and key history is the way I see it, in a very secure and scalable model. And then some technologies aren't capable of that.
We have to end it here. Thank you again,
All right.
Terry.
Thank you.